Hey everyone, and welcome to The Explainer. Today, we're taking a little walk down the street to look at something you've probably stepped on, driven over, or just walked past 1,000 times without giving it a second thought. But actually, right beneath your feet lies this incredible world of hidden physics and high-stakes geometry. Yep, we're talking about the humble manhole cover. It might look incredibly simple, but it actually represents a rigorous engineering decision based on safety, physics, and honestly, sheer brilliance. So let me ask you a simple but kind of provocative question right off the bat. Why are manhole covers never square? Think about it for a second. So much of our built environment is made up of right angles, right? Our doors are rectangular, our windows are square, our floor tiles are square. So why, when it comes to covering a deep, dark, dangerous hole in the middle of a busy city street, do engineers universally reject the square in favor of the circle? If you're a homeowner wanting to understand the infrastructure right outside your front door, or maybe a curious student looking for real-world applications of geometry, consider this explainer your secret guide to the invisible design all around us. By the time we wrap up today, I absolutely promise you, you will never look at your own neighborhood the same way again. All right, let's just dive right in. We're going to break this down into 5 quick parts. Number 1, the constant diameter secret. 2, moving heavy cast iron. 3, perfect alignment every time. 4, resisting Earth's pressure. And 5, saving metal and money. Let's go. Starting with reason number 1, the constant diameter secret. This first point is all about physical danger and a pretty terrifying possibility. The idea of a heavy metal cover falling through its own opening and crushing a utility worker stationed down in the shaft below. Now, what's really fascinating here is how this perfectly contrasts the fatal geometric flaw of the square against the foolproof safety of the circle. You see, a circle has what we call a constant diameter. It doesn't matter how you tilt a circular lid, how you rotate it, or even if you flip it completely upside down. It is always wider than the hole it's meant to cover. It is literally physically impossible for a perfectly circular cover to fall through a perfectly circular hole of a slightly smaller size. But a square? Well, a square has a hidden trap. And that trap comes down to a super specific mathematical factor, 1.41, or, the square root of 2. See, the diagonal of a square is longer than its sides by exactly a factor of 1.41. So if you tilt a square cover completely vertical and then rotate it diagonally across the square opening, that cover is suddenly narrower than the diagonal gap. It's going to slip right through the hole. It's kind of like dropping a square envelope diagonally into a square box. It falls straight to the bottom. Out on a city street, that geometric flaw could be fatal. Moving on to reason number 2, moving heavy cast iron. Shifting gears from gravity and geometry, we really need to talk about pure, punishing weight. Manhole covers are not light. They're designed to survive massive trucks driving over them all day long. And that places an immense physical burden on the utility workers who actually have to open them. These solid cast iron covers can weigh anywhere from 110 kilograms up to a massive 140 kilograms. To put that into perspective for folks using imperial measurements, that's roughly 250 to 300 pounds. Seriously, imagine having to muscle a 300-pound piece of metal by hand just to start your workday. And that brings us to what we like to call the wheel logic. Because a manhole cover is round, a single utility worker can pry it up, stand the cover vertically on its edge, and simply roll it away like a giant, heavy tire. Now think about the limitations of a square. You can't roll a square. If you've got a 300-pound square cover, you have to drag it, scraping across the pavement, or worse, try to lift it by its corners. That is a massive workplace injury just waiting to happen. The circle totally transforms a grueling lifting task into a simple rolling task. Okay. Reason number 3, perfect alignment every time. Think about the end of a long workday. The job is done, and it's time to close up the hole. If you have ever stood in your kitchen trying to wrestle a square plastic lid onto a square Tupperware container, you know exactly how frustrating it is to get those corners perfectly aligned. Now, imagine doing that with 300 pounds of iron in the middle of a busy intersection. So the crucial takeaway here is this brilliant idea of the automatic fit. A round cover has 0 corners. It doesn't matter what angle you approach it from, you just slide it into place and it drops perfectly into the frame every single time. For utility workers operating in low-light conditions, in the pouring rain, or while trying to dodge live street traffic, this lack of corners is a literal lifesaver. It gets them out of danger and off the road significantly faster. Let's move to number 4, resisting Earth's pressure.
Let's take a quick trip underground and see how this builds from surface-level safety down into the hidden physics of soil compression. Because remember, a manhole isn't just a lid, it's actually the cap to a very deep shaft.
To really grasp this, we need to learn an essential engineering term, stress concentrators. In physics, whenever you have a sharp point or a right angle on an object that's under pressure, mechanical stress naturally concentrates right at those sharp corners. Think about tearing open a stubborn plastic package. It is always easiest to start the tear at a sharp notch, right? Well, in underground infrastructure, corners are the exact spots where the immense, crushing pressure of the surrounding earth will cause cracks to form, eventually causing the whole structure to fail. And this brilliantly illustrates exactly why the underground shaft itself is a cylinder. A cylinder smoothly and evenly distributes the compression of the surrounding soil all the way around its perimeter, with absolutely no weak points or stress concentrators. Since the strongest shape for the shaft is a round cylinder, it only makes logical sense to cap that round hole with a uniform, round lid so you maintain the complete structural integrity of the entire system.
And finally, number 5, saving metal and money. Let's talk about the absolute economic and manufacturing genius of the simple circle. When you're a city planner buying thousands of these covers, geometry literally equals money.
If we look at how the math stacks up here, for any given area, let's say an opening just wide enough for a person's shoulders to fit through, a circle has the absolute smallest perimeter possible. If you were to design a square cover with the exact same surface area as a circular one, that square would require significantly more perimeter to enclose the space. And more perimeter means you have to pour more molten iron to manufacture the rim and the lid. By choosing circles, cities save massive amounts of heavy metal and therefore massive amounts of money during production.
Plus, it's incredibly easy for a lathe to machine a round surface to an exceptionally high level of precision. Now, why does this matter to you? Well, next time you're trying to sleep, or you're rolling your trash bin over a cover out on the street, remember that this precision machining means the heavy lid sits incredibly tight inside its frame. If it were a square, it would be so much harder to machine those edges perfectly, and the cover would violently rattle and bang every single time a car drove over it.
So what seems like just a totally random or traditional shape is actually a total masterclass in geometry, weight distribution, structural integrity, and economics. I want to leave you with this final thought today. If something as simple as a manhole cover is designed with this much rigorous, invisible genius, what other perfect geometry is hiding right beneath your feet? Keep your eyes open, keep analyzing the world around you, and we will see you on the next explainer.